So I don't need to give an introduction about what is an Hawkes process or anything. So here I am dealing with a different types of Hawkes process, which is known as marked Hawkes process. So that's different from the Hawkes process that you usually see. So these are the contents agenda. That first of all I will talk about what is Hawkes process. Then as everyone said, in a Hawkes process the important thing is intensity function. A Hawkes process is always defined by its intensity function, and our main task is the estimation of the marked Hawkes process, that I will go later. And the last part, that is the application that comes in finance mostly, is a real data experiments. Some synthetic data also I will apply so that I can verify whether my method works well or something or not. Okay, so before going to the marked Hawkes process, I'll just give you some prerequisite. So a linear Hawkes process that everyone has seen in the previous speakers, Srikanth sir explained one, then my fellow researcher Aditya explained what is an Hawkes process, a linear Hawkes process. So this is the Hawkes process that I explained, where the phi is always remains positive, that the kernel will always remain positive. So for estimating this, there is one method that based on neural network that we have proposed. It is the paper is available in the Journal of Computational Science, named Non-parametric estimation, shallow neural Hawkes, non-parametric estimation of Hawkes process. So in here I am using a neural network for doing that purpose. So this neural network is shallow network in which there is only one hidden layer and one output layer. So the main thing is the activation function. So the network architecture is given under this. This is a network architecture. So there is an exponential activation function and a max activation function. So it's just a two-layered network, and I am using this, and I will estimate the kernel of an linear Hawkes process. So I go next. So next I am taking some other thing we propose is that what happens if kernel takes negative value. That's the thing that mostly we don't observe in financial market. Its application is very low, but as every day we are seeing unfortunate events, so we don't know. Some days there will be something in market where some event occurs and it will decline more events from happening. So that case is defined by this negative kernels. So for estimating that, so this is I am just showing that intensity can negative values. So that can be intensity can never take negative values. Even the kernel will take negative values. So in linear Hawkes process, as it's a sum of an background intensity, that base intensity mu and kernels. If the kernels take negative values, obviously that lambda will go negative. So lambda cannot go negative. Then you are saying that there are more number of events in the past than in the present. So that is not possible. That is in real life condition. So we had to always make it 0. We had to always keep an threshold, 0 threshold, for lambda. So we ensured that for estimating that, we proposed another method known as neural network for non-linear Hawkes. Here also we use a neural network for making the approximation of the kernel. Kernel phi. So here the difference is that there is no exponential function here, so that the kernel can take negative values. So these are the two estimations. These are some prerequisites. These all are. First one is also a paper. This one is also a paper that you can read in archive. This is one in archive. So if someone want more information about it, they can read this in archive. So next we go to the real problem, marked Hawkes process. So what is a marked Hawkes process? As Professor Srikanth has said, when an event happens in a Hawkes process, there is a constant a unit jump. That's a normal Hawkes process. But in a marked Hawkes process, it won't be a unit jump. It will be a varying jump. Every time an event happens, there can be a small jump, there can be a big jump, or there can be a very, very large jump. It can be random. So that's what is known as a marked Hawkes process. So what causes this? This is some events that is attached to the mostly in a Hawkes process we say that the past of the timestamps has an effect on the current timestamp. So maybe the past of the timestamps corresponding factors, that may be in earthquake, it can be magnitude. In finance, it can be volume, it can be price, it can be any factors other than the previous timestamps. So that can make this the non-constant jumps. So we don't know what is the jump will be. It will be it can depend on anything. So we have to estimate that. So here I am dealing with that condition. So yeah. Went to next. So why need for marked Hawkes process? The thing is that earlier, as Srikanth sir again said, the application of initially the Hawkes process was used for earthquake prediction, just to model the aftershocks in an earthquake. So when the earlier thing happens, they only use the past aftershocks in order to predict what it will be the next aftershock. So Ogata in 1999 found that Hawkes was in 1971 up to 28 years in Japan in every area when they are using Hawkes for predicting the earthquakes, they only use the past timestamps. Ogata find that it's not like that. The magnitude can also the magnitude of the earthquake. Currently in Turkey, I think there are earthquake happened. There are 100 aftershocks like that. So within 3 days, the earthquake was 7.8 magnitude. Aftershocks will be usually smaller. But what happened is that there is after 3 days there is an aftershock that is 7.6 magnitude. That is very high. Usually it can happen. So Ogata said that the next aftershock that has a prominent dependency on the past magnitude also. So that's a factor that comes into picture. So when he do the prediction using that concept in an Hawkes process, he get better results. He can betterly determine when the next event is going to happen. So like that, after I will say around 2000, when computational efficiency got increased, then only Hawkes process started playing in finance, I will say. So up to that time, as computational efficiency is low, and I don't know, people don't find that much application of Hawkes process in elsewhere. Mostly its application was concentrated in earthquake prediction. So after that, it comes to finance. So in finance also, in earlier days, people were exploring only the past arrivals. They are not looking into any factors other than that. They are saying that the current arrival only depends on the past arrival. So that was the earlier, most of the papers that you can see, literature will do that. So we are taking out that assumption. So some people also, here is an example. In a normal market, this is a Bitcoin trade market. So this is a 10-second data. So this is what a high frequency data will look like in a real market. Trading, even though it's a 10-second, I think in 10-second also, sorry, it's running. So this is a data comes to a market. This is just a 10-second data. I think around 100 orders are happening. So that's much only uploaded. So in a normal Hawkes process, we will only consider the data are of same size. But when you go to a marked Hawkes process, that will change. When an event is happening, that size of the event will also be taken into picture. So that means that also affects the next arrival of the event. So some people explore these concepts. So most of them consider it as a parametric thing, in which they will assume that the kernel is exponential, kernel is power law. So most of the assumptions means works on marked Hawkes process. Even in finance, mostly they will consider it as a parametric estimation, except the last author, Faber and Talk, he considers a non-parametric technique, but still he has certain assumptions. So we are taking out most of the assumptions that is being considered by the previous author, and we'll go to the intensity. Before going to the estimation, we'll just tell you what is the intensity function of an Hawkes process. So the intensity function of Hawkes process is similar. The only thing is that there is an M comes into picture in the kernel. So we are saying that the kernel is a combined function of previous timestamp and previous marks. The mark can be volume in case of an or price in case of financial applications, or it can be anything in earthquake. It can be magnitude of the earthquake. It been used to model Twitter retweet. When a retweet happens, so in this condition, the N can be the number of followers of the guy who is tweeting. So those kind of many applications are there for in bank default operation. It can be the size of the bank, whether it's a big bank, large bank, what is the size of the bank. So those are the bank marks that can be used. So the marks here we are making an assumption. Actually, that assumption we are making. Most of the papers are making that. This FDM you see, the only difference is that from the previous speakers who discussed, the only difference is that there is an FDM that's coming. Don't consider this phi now. This phi is just representing the non-linearity of the function. So currently just let the psi go, okay. So this FDM, this is a density function of the marks. That the marks, the density function with which marks are generated. So in most of here we are saying that it's independent of anything. It's just it can be a distribution. It can be any distribution. So that distribution we can find out, but we are saying that the next value are independent of each other. That assumption we are making. We can make it a time series actually, but if you make it in a real world condition, in an earthquake or in an whatever the magnitude of the earthquake and the next earthquake aftershock, it's very hard to predict. There is no, until now there are no policy like that which can predict the magnitude, or which can say what will be the volume of the next trade that is happening like that. So here we can make this assumption. This is an assumption we are making, that it's an independent, it's a distribution, and all the values of the distribution are independent of each other. So actually, we can write it as lambda dt into lambda gt into FDM. Lambda gt is this thing, and into FDM we can write where lambda we just call it as ground intensity function. So in a there can be three types of Mark-Hawkes process and intensity function that can exist. One with a combined function of past timestamps and past marks. One in which it's a separate function, means kernel is a separate function and the marks is a separate function that depends on the intensity. So in another condition there will be marks, but the marks doesn't have any dependency. This is a normal Hawkes process. So in here we are estimating all these three types of Mark-Hawkes process. So how will you do that? So an estimation of Mark-Hawkes. So there can be combined function of time and marks, there can be distinct function of time and marks, and there can be there is no dependency of marks. That 5 DGT it can, there is no dependency. Even marks are there, some price magnitude is there. The next earthquake doesn't depends on the magnitude of the previous earthquake. That can also happen. We don't know. So these all three things we will estimate, and for estimating for all these two functions, we'll assume here it as the estimated kernel will be 5 DGTM. They can contain everything, all the conditions that we are earlier said. So here we are model it as a combined function, and the combined function will be also be a neural network. The only difference is that here we had add an extra term for the marks. This is also a shallow neural Hawkes, and this is an extension of the shallow neural Hawkes and the triple NH, that the neural network for non-linear Hawkes that I had discussed in the prerequisite. So this is an extension of that. So if SNH, here it will come exponential and here will come max, and for triple NH here it will come identity function and here it will come max. That's the thing. So why we are choosing both of them, because is that SNH is more computationally effective. Triple NH is little bit computationally more intensive because there is an outside max layer that is coming. If you want to discuss, I will say that you have to go to this paper also. This paper is also in the archive. So I am just giving a gist of it. So here we have a neural network for doing our work. So we apply our neural network. So for estimating we need a loss function. For a neural network, whatever we need some loss function. So here our loss function is the likelihood function of the Mark-Hawkes process. This is actually, you can see in a normal Poisson process, this will be the likelihood function. The only addition is that there is a log FDMN, that is for the density function of the marks. So this will be estimated by the GMM method, that is Gaussian mixture model method. So that I won't discuss in detail. These are means lack of time. So and this part will be estimated by SNH with marks or triple NH with marks, depends on the SNH with marks is usually for linear Hawkes and triple NH is for non-linear Mark-Hawkes. So if we think that there is no negative kernels that can occur, then we can originally stick with SNH with marks. If you think that there is non-linear, that is a negative kernels is there, then we can go with triple NH with marks. Depends on your liking. We can always go for triple NH with marks if you want to estimate. We are not sure. It can estimate linear or non-linear or anything. So yeah. Next we go to some of the synthetic data application. Here we use we generate synthetic data using this 5TM. It's a combined function of marks and time. So here we got the results, even though light mismatch is there, but it's an acceptable result. We plot the QQ plot and we found that it's an acceptable result. So a negative kernel we plot with triple NH with marks because SNH can do this job, negative kernel. So here you see that the fit is far better. So means we can estimate both linear and non-linear Mark-Hawkes process. So we tried with multi-dimensional data also, we got the results. So yeah, this is an interesting application. So what we applied our method to Bitcoin, Bitcoin Ethereum dataset. So that is a cryptocurrency dataset. Why we use Bitcoin and Ethereum is that it is the most traded one. We can use other datasets also of Bitcoin, Ethereum, or I don't know, I forgot all the cryptocurrencies that exist in the market. So there are about 20 cryptocurrencies that exist in the market. You can also use all the this thing. So when you see Aditya's results, you only see self-dependency. That is, along this diagonal only you will see dependency. So what here is that there is also two mutual dependency that is easily seeable, you can see. And this mutual dependency depends on the marks also. This marks is the volume. Here marks is the volume. Sorry to say that. The order volume is the marks. So you can see that there is self-dependency and there is also cross-dependency. And this cross-dependency, I am just zooming it in, says that it depends between Bitcoin cell and Ethereum buy, and Ethereum buy and Bitcoin cell, Ethereum cell, sorry. So it says that there is dependency between when Ethereum trade happens, it can excite Bitcoin trade. That was it saying. And that's actually in real market, we don't know why it's happening. It's you have to means we know that someone is when someone is buying, they are buying Ethereum by selling Bitcoin. That is happening, we understand, but we can't explain why this is happening. We have to more stretch in the macroeconomic phenomena to check. But the opposite is not observable. Here you can see that this is Bitcoin buy and Bitcoin sell, but it doesn't depend on Ethereum on anything. That events are not dependent on Ethereum on any factor. So that's the conclusion we observed. So I am just concluding. Here we use a two-layered network, and why use two-layered network is that it's very simple, and there is no black box thing that exists in neural network. It's really a black box if you do a lot of hidden layers. So that thing we can usually avoid in this method. So, and one more thing that I have to show is that we also give a QQ plot to say that whether if volume is having an immediate impact on the next trade arrival. So we see that Bitcoin sell has an impact and Ethereum buy has an impact on volume. The others, even though if you didn't take the volume, it doesn't have that much impact. So these two have an impact on the next arrival. For volume has an impact on the next arrival. These two things we didn't observe. So that we concluded that if you want to have Bitcoin place an orders, and then on this side, then you have to definitely consider the volume of the Bitcoins. So yeah, for more this thing you have to, means I am just give a gist of it. You have to go through this paper. So I think I completed in time, I think. So thank you.